We are building on the concept that we learned from the previous video where we took time to understand the logic behind data type 2. So for this session, we will be looking at how to find the mean for data type 2 because that's a journey. Well, as we did it for data type 1, we find the mean for data type 1, mode for data type 1, and the median for data type 1. Now that we have understood the logic in the previous video on how data type 2 is important and why we need it, we need to now find how to find the mean of this data type 2. So we'll be using the example, we'll be on the examples that we solved or the conversion that we did in the previous session. Yes, so we will start with our first example, which is this one. So this is what we found. We just use it to understand or see the structure of data type 2. Okay, for this session, we will be using this to find the mean. Now, to find the mean, what do we say when we are doing data type 1? It's like squeezing the items together and dividing it by the number of items. If you watch the previous video, we look at something how to find the number of items, right? The total count of items. We call this sigma f, or the total frequency. Frequency means counts, and if you want to know the total number of items, just add all the frequencies together. That will help you to find the total number of individual elements. That's the total number. So we know the denominator already. So if it's your data type 1, we're counting individually 1, 2, 3 up to the end. But for frequency, we know that for each item, this is the number of it. For this item, this is the number of it. So if you put the number of elements together, it's like you are finding all the total number size, right? So if you sum all the frequency, you are getting that number that you have to divide by. Sorry. Now we need to find the sum of all the items. So we are dealing with numerical data, so we need to find the sum of all the number of items before we divide by the total number of elements. So remember that in data type 1, we find that the mean is equal to sum over the number of x, the number of items, or the items, you represent them by x. That's why I say x. So total number of items. But in this case, we are having the frequency. So the total number of x that we said. To find the total number of x, what do we do? What did we say? We said in the previous video that each of the counts, so 2 appears once, 4 appears 7. So it's just reasonable to just simply add all these items to find the total number of. So our total number of xs is the same as the sum of all the individual frequency, and the sum of all frequency will be everything that we have here. So let's see. 1 plus 7, that's 8, plus 6, that will be 14. 14 plus 5, that's 19. 19 plus 3, that's 22. 22 plus 4, that's 26. 26 plus 3, that's 29. Yes, 29. So we have total number of items to be 29. That is our nx, the denominator for what we found. But now we need to find the sum of all the elements, right? The sum. So we are summing the items. See, we say 2 appears once, 4 appears 7 times. So for each of them, right, we need to find the number of 2's. So we say 2 appear once. So if you do that for the 2, what's the sum that we are getting from the total sum of 2's? So total sum of 2's is, so 2 is an item, it appears once. So 2 times 1 will give you 1. Now, if you have the item 4, how many times does the 4 appear? 4 appears 7 times, right? 4 appears 7 times. So if you want to find the sum that is accumulated by 4, or the total sum of all those 4 items, so you just multiply 4 by 7, right? So for the first case, we are going to do what? 2 times 1, then we give us 2. So that's, we are multiplying. You know each item is 2, right? And it's appearing once. So this is the frequency, and this is the item here. Yeah, so the item I said is x, and f is this. So this is my x, this is my f. So we have 2 appears how many times? Once. That's why we multiply by 1. We have 4 here. In this case, 4 we multiply. 4 appears how many times? 7 times, right? That's why we need to multiply 4 times 7. 4 times 7, that's 28. That's what we have there. So yeah, basically that's how we do the so you need to find the sum of all of them, right? You need to find the sum of all items. So for item 2, it appears 1. So to find the total sum of the 2s, yes, 2 times 1 to get the bulk or the sum component that is brought by all the twos. If you have 4, right, you say 4 appears 7 times. So if you want to sum all the 4 items 7 times, just do 4 times 7. The same thing goes for the 5 appears how many times? 6 times. So if 5 appears 6 times, so we need to do what? 5 times 6 to have what? 30. Like that. So we want to do for 6. 6 appears how many times? So 6 times 5 also give us 30. Then a 7. We say 7 appears 3 times. So 3 7, that's 21, right? Then you can use your calculator to be doing this fast. So I'll use my calculator soon so that you don't feel like you have to do it from your head. So 8 4, that's 32. Then the last one that is brought by 9. 9 by 3, then we have 27. So this is the sum of the nines. All the nines in the data set is 27. The sum of all the eights in the data set is 32. The sum of all sevens is 31. The sum of all is 30. The sum of all 5 is 30. So yeah, this is all the sum for each from each component, right? But if you want to find the total sum, we need to put all this together, because mean is what? Mean is sum over total number. So we have the total number of items here, but we need to find the sum of all the components divided by the total number of elements, or the total number, which is the sigma f. So I'm trying to link why we are doing the multiplication, why multiplying each item by 1, right? We are doing numerical data, right? That's why the items are numbers. So you want to find the sum of all those numbers. To find the sum of all those numbers, we need to multiply that item or that number by the number of times it appears, so that we know that, oh, 2 times 1 is 2. So in the data set, 2 appears 1. So the sum that we get from 2 is just 2. The sum of all the 2's is 2. Now if you count 4, 4 appears 7 times. So the sum of all 4 is 7. 5 like that, 6 by its number of times. At the end of the day, you have the sum from each component, right? But then we are looking for the sum of everything, all the components, all the items together in the data set. That's why we need to find, after doing the sum of all this, right? So what we get from here, what we are going to have from here for this is fx, f times x, frequency times x, frequency times f. That's what we got here. Down that data set, this is what we have, the sum for each component. Now, but then we need to add all of them. So we need to add what? All the fx. So sigma means what? Sum of all fx. We are going to sum all the fx, right? Fx is item times item, but items times frequency or count. Items times frequency or count. But when we are done, because we are looking for the sum of everything to find the mean, we need to sum all those items now together. So that's why we needed the sigma f here. Yeah, so we now need to put them together. Let me get my calculator so that I will not do any mistake by trying to solve it from my head. Let me get you this my calculator. Yeah, I hope you are getting the logic, right? That I don't want you to go out there and be chewing the formula or trying to find mean. No, understand how mean works, right? Mean is trying to find the sum of that. So why are we multiplying? Why are we using this formula? As at the beginning of this, that's what I said. I'll tell you why the data goes like that and why it's done like this. So this is the reason behind it, right? We are just basically doing data type 1 in another way, right? So that's why it's important to watch the previous video to understand the logic. Now we come here, it's easy for you to get it. Now my calculator is ready, so I have the first is my the first fs is 2, right? The second one is 28 plus 30 plus 30 plus 21 plus 32 plus 27. Yeah, so I have 170. So this is the sum of all the items now. So we finally have our sum. So we say that our mean, so sigma, we say mean is equal to the sum of all items over the number of items. But we know that the sum of all items here in this case is just basically the sum of all. So item times is what? The number of times they appear divided by the sigma f. Sigma f is just basically referring to this guy, and this is referring to this guy. Because in this case, that's the way we can do that, right? So now when we did that, we have 170 over the number of items is 29, right? You have 29. So let's find the mean. is 170 divided by 29. Here I have 5.862. So you can stop at 2 decimal place, or the question didn't say, right? But basically stop at 2 decimal place for convenience. 2 decimal place. So yeah, anything around this is correct. Like you can have 5.86, no problem. If you want to do 1 decimal place, which I don't advise, if the question didn't say it, if the question didn't say anything, just use 5.2 decimal place, right? So 5.9. But I don't advise this. So for more accuracy, use 2 decimal. If the question precisely say 1 decimal place, 2 decimal, 3 decimal place, follow that. But for when here is not asked, stop at 2 decimal place. Yes. So this is basically, and what I, for the type 2, if you read the textbook, they will say that, oh, mean is equal to sigma fs over f, sigma fs over sigma f. It shouldn't be something that you are achieving. It should be something that you understand why it's being done. So it's just that type 1. Because the things, there are a lot of repetition, right? You need to put them in a table. If you put them in a table, now you have data type 2. It's now in another format, which is data type 2 format. Now we have the data type 2 format. We can easily do the sigma fx over sigma f. Why are you doing sigma fx? Sigma f is just the total number of items, which is you get from the count. You sum all of them. Now sigma just means sum. We said that many times, a lot of times. And then sigma fx, f times x is just like the count times the item, which is 2 times 1 here, 4 times 7, and 5 times 6. So that's the formula that we generally use, right? So now let me get you to another example that we also brought from the previous um we have. So yeah, this is what we have. This is what we have. This is what we have. This is what we have from the previous video. Then what do I have? What do I have? What do I have? 1 by 4, right? So we have sigma f from the previous video, right? Sigma f with the sum of all these things. We did it already. Then it's left with finding the sigma f, right? So I'll clean this side so that we did do it as we know that sigma f x is our. So what I will do is that I will call this fx. I will call it fx like this. Yes. So I'll have this. Yeah, so now 4 times 1, right? So fx, f is the frequency, x is what? S is the item. So here you can call it x. So what do I have? 1 times 4, I have 4. 2 times 10, that's 20. So 2 appears 2 times. So if the sum of all the things that you can get from 2 is 20 times 3 times 16, so 3 by 16, I have 48. 4 by 11 is 44. 5 by 9 is 45. 6 by 5 is 30. 7 by 3 is 21. So let me get my sigma fx, the sum of all my sigma fx. We know why we are using sigma fx. We are not, you just don't know that that's sigma f. You understand why it comes like that from data type 1 leading to data type 2, right? The most important thing to me is you understanding why we are using this, right? So let's use, I have 4 plus 20 plus 48 plus 44 plus 45 plus 30 plus 21. Yeah, so I have 212. Now sigma f, when we did it, the sum of all the f's, what do we have? We say we had 58. So now what's our mean? Our mean for this data type is going to be sigma fx all over sigma f. Then that means 212 over 58. So 212 over 58, 212 divided by 58, I have 3.655. So anything around 3.66 is also fine for 2 decimal place. I mean, I mostly go to 3 decimal place before trying to run it to 2 decimal place, so that fine. But pay attention to the question again. Yes. So this is how to find the mean for data type 2, and just basically not going to just choose the formula sigma fs over sigma f, no, but it's still data type 1 in another way. But I want you to see the link, the correlation, and why they are doing that. The reason why they are doing that, that's why we need to take time and understand, so that you not be hot when you are doing your WASI, right? So yeah, this is understanding, and I hope to see you in the next video where we look at how to go about finding the mode of the data type 2. Thank you very much. Like and subscribe.